Injective function, a function f that maps distinct elements to distinct elements. That is, f of x sub 1 is equal to f of x sub 2 implies x sub 1 is equal to x sub 2. For example, we have set A and set B. Let's just say that set A consists the numbers 1, 2, 3. And set B consists the letters A, B, C, and D. One is to A, 2 is to D, and 3 is to B. Surjective function, a function f that maps an element x to every element y. That is, for every y, there is an x that f of x is equal to y. For example, we have set x and set y. And it consists 1, 2, 3, and 4. Then A, B, C. 1 is to A, 2 is to B, and 3 is to C, and also 4 is to C again. So, in other words, every element of the function's codomain is the image of at least one element of its domain. It is not required that x be unique. That function of may map one or more elements of x to same element of y. Let's talk about bijective. Bijective is a function f from set A to B is bijective if for every y in B there is exactly one x in A such that f of x is equal to y. Bijective. Alternatively, f is bijective if it is one-to-one correspondence between those sets. In other words, both injective and surjective. So here is the example of bijective. If f is the function of R to R defined by 2x plus 3, then we have to prove it if it is bijective or not. So here is the solution. So if the function is bijective, then it must satisfy to one-to-one correspond or one-to-one function. Then we have to solve first the one-to-one function. f of x sub 1 is equal to f of x sub 2. Then, two x sub 1 plus 3 is equal to 2x sub 2 plus 3. Then, we have to cancel 3 on the both sides. Next, 2x sub 1 is equal to 2x sub 2. And again, we can cancel 2 on the both sides. So, we get here x sub 1 is equal to x sub 2. Therefore, f of x is equal to 2x plus 3 is bijective because it is one-to-one function. Invertible function. A function is said to be invertible when it has an inverse. It represented by f negative 1. Condition for a function to have a well-defined inverse is that it be one-to-one and onto, or simply bijective. So if you're asked to graph a function and its inverse, all you have to do is graph the function and then switch all x and y values in each point to graph the inverse. Just look at all those values switching places from the f of x function to its inverse g of x and back again, reflected over the line y is equal to x. So we have an example here using a mapping diagram. Let's say A that consists 1, 2, 3, 4, and set B that consists the letters A, B, C, and D. And I define the function f to map 1 to A, 2 to C, 3 to B, and 4 to D. So, to find the function that is inverse, if I have set B, which consists ABC, ABCD, and set A that consists 1, 2, 3, and 4. I want A to go back to 1. B to go back to 3. C go back to 2. And D go back to 4. So this is what we call function f and function f, and this is function g. Well, in this case, we refer to g as the inverse of f, or we write it like this: g is equal to f negative 1. It is how we explain and describe the invertible function using a mapping diagram.